Okay, let's discuss how it works when we combine form and orientation tolerances. So we can use a multiple single segment feature control frame applied to a single feature, and we can control orientation to one value, and typically we would control form to a smaller value. This is only required when maximum allowable form tolerances are less than the allowable orientation tolerances. We'll explain what that means. And really, I don't think you only need this. It's also needed when an orientation is applicable to a tangent plane. So let's talk about this a little bit more. Um, so the surface form must be as good as the orientation tolerance, and you're only going to apply a form tolerance when the requirement's smaller than the orientation tolerance. And the exception is when the orientation tolerance applied to a tangent plane does not control form. So let's see what that looks like here in this slide right here. So orientation and form tolerances are applied to a surface. Okay, we're talking about a model representation here. We have a datum A here, and then we have a perpendicularity tolerance of 12 thousandths on the surface right here to A, and also a flatness tolerance is of 4. Okay, so again, we always said in previous slides that the form tolerances are much tighter than the orientation tolerance, and this is a good illustration of this right here. So really what we're looking at here is we have this 12 thousandths, and that's the perpendicularity tolerance zone is constrained in rotation of datum A. That's these two lines here represent our 12 thousandths perpendicularity tolerance. And then within that, we have to control flatness to a tighter tolerance of 4 thousandths. So wherever these surfaces line up, we would run an indicator over that and make sure that they don't vary by more than 4 thousandths in terms of full indicator movement. Okay, so we're connected to a single leader terminating with a dot. That's how we do it on the model. It may have separate leaders for each feature control frame, or we can put the two control frames together. And it's commonly organized to place the larger tolerance zone first, so the larger tolerance zone is listed on top. And so this is a means of refining a surface, if you will, both for perpendicularity and then for tolerance. Flatness tolerance. And here let's talk about this on a feature of size, and this would be for a pin. So orientation and form tolerances. Okay, in this case we have an orientation tolerance of 15, and then we have a form tolerance, a straightness of 5. So what does that mean? Compliance check by finding the unrelated actual mating envelope. So when they talk about the unrelated actual mating envelope, there's an actual unrelated mating envelope for the straightness tolerance, and it's not necessarily related to the perpendicularity tolerance zone either. The RFS form tolerances control derived median lines or planes, and then compliance is checked by finding centers along the pin and determining if they're within tolerance. And when we talk about that, RFS. So really what we would have to do is we take these points here and here from one side of the cylinder to the other side of the cylinder, and then we establish a center line for that based on those two side points, and then we make sure that that center line fits within this axis. Again, the axis method is very stringent and it's very difficult to check. We'd rather would use the surface method, but that's only applicable for when MMC modifiers are applied. And then here's our last slide that has to do with orientation and form tolerances on a feature of size still. So both the MMC orientation and the form tolerances will create a virtual boundary. Okay, so in this case we have a virtual perpendicularity virtual condition, and then we also have a straightness virtual condition. So both the MMC orientation and form tolerances will create a VC boundary, and the feature surface cannot violate the boundaries. That's the surface method. And then both control surface form. It's possible to show a form tolerance that's much less than an orientation tolerance, And the other thing is the MMC orientation and form tolerances do not accumulate because form is also controlled by orientation at MMC. Okay, so this concludes our Lesson 7 slides. Thank you.